Hi, this is Hassan Korani. In this video, we are going to start a new chapter which is about functions. That is very important title in mathematics for its useful applications in physics and generally in science. The objectives of our chapter are explore the concept of functions, determining the domain of definition of a function, studying the graph of a function in coordinate plane, even functions, odd functions, and at the end we are going to start to study how to construct a table of variations of a function. At the beginning, what is a function? Let's see. When one thing depends on another, for example, the area of a circle depends on the radius, in the sense that when the radius changes, the area will change. Then we say that the first is a function of the other. The area of a circle is a function of, or it depends on the radius. This can be illustrated in this activity, as you will see. As you know, if this is a circle with center A and radius R, the area is pi r square, and this is a formula for the area. And as you know, the area depends on the radius. As the radius changes, the area will change also in this manner. So we say that in this case the area is a function of the radius. For each radius we have a certain area for this circle or disk, and this is illustrated in these words. Mathematically now, the definition says that of a function says that a rule that relates two variables, typically x and y or something else, is called a function if to each value of x the rule assigns one and only one value of y. And this is a very important point. We have to fix it on our mind. When that is the case, we say that y is a function of x. Thus, a function must be single valued. For example, y equals 2x plus 3. For each x, there is a unique value of y. We must have only one value of y for each x. So a function in general is a relation between two variables, in general y and x, with a certain property. Let's consider another activity. Let's say we have these two sets of numbers 0, 1, 2, 3, 4 related or assigned to this set by this relation y equal to x plus 1. And these are the x values or inputs, or sometimes we call the domain of this relation or function. And these are the outputs by this relation. For x equals 0 here, y will be 1. For x equal 1, y will be 2. Or 3, sorry, for x equal 2, so the output, the y, will be 5, and so on. And this can be illustrated by this. Let's consider the function or the relation as this machine that works on the inputs, these inputs, that work on them by multiplying each input by 2, then we add 1 to it, as you see in this animation, to give 1, 3, 5, 7, and 9. This is the concept, the main concept or the general concept of a function. Let's see another examples. Let's consider these two sets. The initial set contains these elements a, b, c, d, and the final set contains the elements m and o. A related to m, B is related to M also, C related to N, and D related to O. Now, is this a function? You must ask yourself, is each element in the initial set related to one element in the final set? And the answer will be true, since A related to just M, B related to another, to one output. So by this way, we can notice that this is also a function, since for each element in the initial set we have one and only one element in the final set, and no problem if we have an element in the final set related to more than one element in the initial set, but the converse will be unallowed. As you see here, in the initial set we have elements A, B, C, and the final set we have M and O, P. But in this case, as you see, we have an element which is A is related to two elements in the second set. So for this reason, we can conclude that this relation is not a function. In fact, it's an ordinary relation, but it's not a function, since we have an element X in the initial set related to two elements, to two outputs, and this is not allowed in functions. Let's see another example to understand very well the concept of a function. Let's consider this set that contains persons, and there is a relation between the initial set and the final set. Initial set contains persons, and the final set contains the weights of some persons. So Bilal is related to the 62 kilograms. His weight is 62 kilograms. Also Khalil and Salma. So while in the other persons are Ala and Hadi or Aziz are related each one to a certain weight. As you see, the important idea here now, to know if this relation is a function or not, just ask yourself, is each person or element in the first set related to one and only one element in the second set? And this is true here in this example, since for each element X person in the first set, one and only one element or weight in the second set. And this is logically, since each person has one and only one weight. It's impossible to have for the same person two weights at the same time. And by this we can conclude that this relation is a function, in fact. Let's see another mathematical functions. Let's consider this function, this relation y equal x squared. If we give this relation 1, it will be 1 squared 1, and if we give it minus 1, it will give also 1. If we give it minus 2, it will give us 4. Also 2 will give us 4. And this can be illustrated by a relation between sets 1 and minus 1 related to 1 according to this relation: 1 square 1, minus 1 square also 1, 2 square 4, and minus 2 square 4. Now, as you see, each element in the initial set related to one and only one element in the second set, and this leads to say that this is a function, in fact. Another example, y equal absolute value of x, the absolute value function or relation. Since we have, if we give it 0, it will give us 0. For input 3, absolute value of 3, 3. Absolute value of minus 3 is also 3. Absolute value of 4 is 4. And the absolute value of minus 4 is also 4. By this way, if we illustrate this in the relation of sets, absolute value of 0, 0, 3 minus 3 also 3, absolute value of 4 and minus 4 also 4. And for each element here in the initial set, we have one arrow related to the second set. So this is also a function in mathematics. Functional notation. This is very important to know. Say that we are considering two functions, two rules for determining y equal x squared plus 1, and another relation on another function, y equal 5x. Let's call the function, the rule y equal x squared plus 1 by the name f. And let us call y equal 5x by the name g. We write the following: f of x equals x squared plus 1 and g of x equals 5x. We read this: f of x equals x squared plus 1 and g of x equals 5x. Here you have to note that the parentheses don't mean multiplication of f by x. it is read f of x, and they are part of what is called functional notation. F here is the name of the function, g here is the name of this function, and this helps to differentiate between this y and that y. Since both are written in the form of y equal in terms of x, here y equal x squared plus 1 and y equal 5x there. So in order to differentiate between them, it's helpful, it's useful to name them by f of x, g of x, h of x, or what else. And whatever appears within the parentheses is called the argument or the input. Here, the input is x, as you see. In both functions, the input is x. Thus, the function f has been defined as follows: f of x equal x squared plus 1. This means that the function f will square its argument or input and then add 1 to it. For example, f of minus 5 squared plus 1, it will be 26. We say that the image of minus 5 by f is 26. 26 is the image or the output. We call it usually in mathematics the image of minus 5 by f. And we say that an antecedent of 26 is minus 5, or a pre-image of 26, a pre-image of 26 is minus 5. F of 2 equals 2 squared plus 1 according to this function, which is 5. We say that the image of 2 by f is 5. So 5 is the image. Image of what? Of 2 by f. And we may say that 2 is an antecedent or pre-image of 5. This is for naming. F of t, for example, the input if t is t squared plus 1 according to this function. And also if the input is x plus a, so according to this function f works on this input, it will square this input and then add 1 to it. As you see, f of x plus a equals x plus a squared plus 1. That is x squared plus 2ax plus a squared plus 1. This is the output, all the output. And input x goes into f machine, out comes x squared plus 1. And this is one of the ways to represent a function. This is the name of the function, this is the input, and that is the output. This is the end of part 1. Thank you for watching. See you in the next video, and goodbye.